Welcome, everyone. We're going to do a quick survey here of Chapter 7, Climate Zones and Biomes. This is part 1 of 2. So if you recall, we did discuss weather and climate many times in the class so far. Weather was a description of atmospheric conditions for a specific time in a specific place, so it changes all the time from one place to another and also from one time to another. And climate, conversely, is the long-term atmospheric conditions over many years, 30 to 100 or more years. And we're trying to find out within that time period, what are typical conditions, but also what are conditions like during the hottest month, the coolest month, the wettest month, the driest month, if we even have those, because some places will have a climate where it's pretty much wet throughout the year, pretty stable temperatures throughout the year. Other places will have cold times of the year, warm times of the year, wet times, dry times, etc. So we'll have an analysis of climate in particular. And when we're doing that, we're going to pay particular attention to the temperature and precipitation regimes for these regions, not particular spots on the planet, but large areas or regions on the planet. If you recall, there are 7 major things that do tell you or tell a climate what's going to be in that particular region. So what's going to control that climate? And those include latitude, maritime versus continental. So is a place on a coastline or is it in a continental interior? We've referred to that in the past as distance from a large water body. We have ocean currents. Sometimes they're warm, sometimes they're cold. So a place on the coast might be influenced by a warm ocean current, and that's usually going to be a pretty humid place, or a cold ocean current. And cold water off the coast tends to chill the air down and make it sit still, maybe give you more fog than clouds. So those tend to be drier places. Land barriers, particular topographic land barriers, those are going to steal the moisture on one side of the mountain and give you a rain shadow on the other side of the mountain. Winds and pressure belts, we've learned about that from our prior chapter. Some places on the planet are dominated by low pressure and rising air, and therefore they're going to be cloudy and probably wetter places, whereas other places are dominated by sinking air in high pressure belts, and those are going to tend to be much drier places. We talked about storms, in particular in our last chapter. We talked about the various types of storms, and those storms are on tracks, or let's say that they are more apt to impact some areas of the planet and less so different areas of the planet. So if you are located, or if a place is located in a track of a storm, it's going to tend to have or be impacted by those storms more and therefore have more moisture. As far as elevation, the higher up a place is located on the planet, the further it sticks up into the troposphere, and therefore it will tend to be cooler than places that are lower in elevation. So that's just a quick refresher of those topics. Now, in my class, we've already discussed the Köppen climate classification, the lettering system. Quick review. Vladimir Köppen used the capital letters A, B, C, D, and E to represent A, tropical. Those are going to be found in equatorial regions of the planet. B are going to be dry places. These are arid places dominated by deserts, but also including an area what we refer to as steppes. C, mesothermal. Meso means middle, so these are going to be mild temperature places. Usually we find these in the lower mid-latitudes. So if we divide the latitudes, or if we define them as approximately 30 degrees to 60 degrees in latitude, the lower portion of that would be 30 to 45 degrees. And that's pretty much, it's not entirely, but that's where we find a lot of these C climates. The D climates, the microthermal, that means small temperature, these get very cold winters. And we tend to find these in the mid-latitudes, but in the upper reaches. So let's say 45 to 65 degrees latitude. And we'll see later on, this is only in the northern hemisphere. These are continental climates, and we're going to see these only in places between about 45 and 65 degrees latitude where we have large continents. And that limits us to the northern hemisphere then. We don't have those large continents at those latitudes in the southern hemisphere. And then finally E, a polar climates. These we'll see have two categories, the polar tundra and the polar ice cap. These are always pretty cold places. In fact, one of them has an average temperature that's below freezing every month of the year, and the other type, the tundra, thaws out a little bit. So Köppen clearly saw that latitude is a major or dominant feature in determining what kind of climate a place has or a region has. So we go here from A, B, C, D, E. A in the tropics, B in the subtropics, C the lower mid-latitudes, D the upper mid-latitudes, and E polar. Now Köppen also had an H climate, the highland climate, and this basically acknowledged that any place on the planet can have ice caps year round. Doesn't matter where it is. It could be in the tropics, it could be in the poles. And that could only happen if that place or that region stuck up high enough into the troposphere. So in places where elevation is significantly high, even at the equator, let's say 16,000 feet of elevation at the equator, and you've got ice probably throughout the year in those mountainous regions of like New Guinea and Ecuador. In these cases, it clearly falls out of our regular pattern. So if elevation becomes a dominant factor in why a climate exists in a certain region, then we just refer to that as a highland climate. So we have our capital letters. We haven't addressed all of them yet. We have second capital letters that go with only a few of these initial letters. So the capital S refers to steppe, capital W refers to desert, the capital T for tundra, and the capital F for ice cap. So our letter systems, we have just capital A, we have capital B, capital S combined for dry steppe. We have capital B with capital W for dry desert. We have capital C by itself. We have capital D by itself. Then we have capital E with capital T, polar tundra, and we have capital E, capital F for polar ice cap. Now we also have lowercase letters representing several things. First of all, precipitation, represented by lowercase f. This means a place is wet all year. Lowercase w, again, that's lowercase. So lowercase w means winter is dry or a winter drought. Lowercase s means summer is dry or summer drought. And lowercase m, monsoon. Third lowercase letters. We have 6 of them. H, all these refer to temperature, by the way. Lowercase h means a place is hot. Lowercase k, cold. You might be asking, why is that not a C? Well, in German, the word for cold is kalt. It begins with K. And Vladimir Köppen was a German speaker and German writer, so he uses those Germanic words or the letters for them. By the way, in German, hot, the word is heiß, beginning with H also. So H, hot, K, cold, and then A. This refers to pretty much how hot the summertime temperatures get. So lowercase a, temperatures are pretty hot in the summertime. Lowercase b, a little bit cooler. Lowercase c, even cooler. Lowercase d, even cooler. So for summertime temperatures, and these lowercase d climates get very, very cold winters too. I'll give you an example here. Glendale, California, Pasadena, California, located 20, 25 miles from the coast or so. These will get very, very hot summers. So we're going to have a lowercase a in Glendale for our climate region. However, if you're at the coast like Santa Monica, Redondo Beach, Santa Barbara, they will have a lowercase b at the end of their climate system letters. So temperatures not quite so hot along the coast as they are inland. And talking about that, let's put some of these letters together. Capital C, lowercase s, lowercase a. This is known as a Mediterranean climate. It's found in the lower mid-latitudes, typically 30 to 45 degrees of latitude, with a dry summer that's quite hot. So this is referred to as a hot Mediterranean climate. And this would be indicative of Glendale, Pasadena, Northridge, the inland portions of Southern California. Now, let me rephrase that, the inland coastal portions of Southern California, because Mediterranean climates are all going to be pretty close to the coast. However, if you're at the coast, you would be a CSB. And if you're just a little bit in from the coast, a CSA climate, where those summer temperatures start to heat up. You go too far inland, you're not in the Mediterranean climate anymore. So here's a quick summary. I'm going to get rid of myself out of the video. I'll say bye-bye for right now, at least the visual portion. That gives you a little bit more room right there. So basically, I've itemized the letter system here. You can take a look at that. You will be responsible for knowing some of this, because if you know the symbols, it's going to help you understand those climates quite a bit more. So do take a few minutes to look at this. I'll typically give this as a homework assignment, or we'll do it in class to go over what those letters mean. Whenever we're looking at climates, we're going to also look at climographs. Now, we can't actually see the climate. It's air, right? But we can measure that air. We can measure that atmosphere. And we can also get a proxy for that visual by looking at the landscape or the vegetation that's found within these regions. So we make some assumptions if we look at, or if we look through the air and see a landscape or see the vegetation. But the measuring part is plotted on a climograph. And remember, the two things we measure for the climate would be temperature and precipitation. And we do this over long time periods, but we look at it for each month of the year. So along the base axis here, we have January, February, March, April, May, June, July, August, September, October, November, December, the months of the year. And we have two different things graphed here. One is the temperature and how that changes throughout the year. So here we have a temperature regime. This, by the way, is for St. Louis, Missouri, and it shows we get pretty cold temperatures in the winter. This would be less than 30 degrees Fahrenheit, so we're looking at average temperatures lower than freezing, below freezing, gradually warming up later in the winter and through the spring, and peaking in about July or August. And that's pretty typical, because that's 1 or 2 months after the solstice. We get our hottest temperatures. So average temperatures over 80 degrees, that means, remember, that's the average of the daytime and the nighttime. So you add those up and divide by 2 to get the average temperature. And we're looking at averages over 80 degrees. That means probably daytime temperatures in the 90s, cooling off to the 70s around sunrise. That's pretty warm conditions. But not only is that warm, they're also getting precipitation during those summertime months. So that means the air is still pretty moist. And you know how that feels when it's pretty warm air and pretty moist. That humidity, pretty nasty. So for me particularly, I would probably avoid going to St. Louis, Missouri during the summertime, because I just don't do well in those kind of hot, sticky conditions. Now, as we get past August, temperatures start to drop all the way until December, January, reaching the lowest average temperatures again around January. We can see that for St. Louis, cold temperatures with precipitation. Cold temperatures with precipitation. Warm temperatures with precipitation. Pretty much wet throughout the year, with a significant annual temperature range, the difference between the lowest and the highest average temperatures. Total precipitation for St. Louis, about 40 inches per year. That's a little bit more than double what we get at Glendale College. And the temperature range, the annual temperature range, about 47 degrees. And that's probably also very close to double what we get at Glendale College. So our climate regions, we're going to explore these one by one. We'll look at some key statistics, and then we're going to also take a look at a climograph or two for each place, and then we'll look at the associated vegetation. So we can see here, this is climate regions around the world. They fall into tropical climates, then the dry climates, then we have the mesothermal, the C climates, then we have the microthermal or continental climates, the D climates, and then finally the E climates. We'll also take a look at highland at the very end. If we look at the pattern here, we're going to be starting off in the tropics. Let's look at Africa here. We'll start in the tropics and look at those tropical climates, and then we're going to move into the B climates, and then we'll move into the C climates, the mesothermal, and then the D climates, and finally into the E climates, the polar climates. So we're going to take a trek basically from the equator towards the poles. As we're doing that, again, we're looking at climate, but we also have to link it to the vegetation. These are vegetation zones around the world. And we're going to look at what type of vegetation we find in those A climates, in the B climates, in the C climates, in the D climates, and in the E climates. And we'll see that in both cases here, we see a pattern where if you move east-west, chances are you're not changing your climate or your vegetation that much. So we'll find tropical rainforests here in equatorial South America and in equatorial West Africa and in much of equatorial Southeast Asia. If we want to look at the world's great deserts, we'll find those close to 20 to 30 degrees north latitude. They bump up a little bit because of some mountain exposure here, and 20 to 30 degrees in North America. So these same bands run east-west. So if you run east-west, probably not changing your climate that much. If you're moving away from the equator by changing your latitude, we can see significant and quick changes in your type of vegetation and type of climate. So the key here is basically that the dominant factor in what type of climate you get is latitude. So if you change your latitude, you're probably going to change your climate. And then what determines the vegetation is the climate. So your vegetation is determined largely by your climate, and your climate is determined largely by your latitude. Now there are some exceptions there, but that is the general rule, that latitude is a very dominant feature here. Okay, so these large regions of vegetation, we refer to those as biomes. So in essence, our biomes are largely determined by our latitude and our climate type. Again, climate determined by latitude for the large part. Biomes, these large ecosystems, the vegetation and plants, animals, these will be determined largely by climate. Okay, our first climate zone to be discussed is the A climates. And there are three types, A, F, A, M, A, W. So A, tropical. F means wet all year, we call that tropical wet. A, M, tropical monsoon. Those are monsoonal climates that are going to be influenced by those heavy summer rainfall regimes with a drying out in the winter. And then a W, sometimes referred to as tropical wet and dry or tropical savanna, and these climates have pretty much half the year wet, half the year dry, hence the word tropical wet and dry. So we're going to look first of all at the tropical wet, then we're going to look at the tropical monsoons, which we find on the edges, and then we're also going to look at the tropical wet and dry, which we find a little bit further away from the equator. If we remember, the ITCZ is located very close to the equator, but as the seasons progress, let's say as we move into the northern hemisphere summer, the ITCZ is going to shift a little bit north. As we move into the southern hemisphere summer, the ITCZ will shift a little bit south. So the key feature we're going to find here is that these tropical wet climates are under the influence of the ITCZ throughout the year. The ITCZ is a pretty thick band of low pressure, rising air, or rainfall. And it covers this area all year. It will shift, the ITCZ will shift north of the equator, but including the zone in northern hemisphere summer months, and it will shift south in the southern hemisphere summer, covering this entire zone here and leaving this dry. So with that shift, we're going to see, are these places under the influence of the ITCZ throughout the year, or only part of the year, or most of the year? With the three different types, we'll explore that concept. So again, tropical wet, tropical monsoon, tropical savanna. Tropical wet. I know there's a lot of details here, but these are some of those key details. I'll read off some of them and we'll explore it a little bit more. So the tropical wet climate zone is found typically, but not only, but typically 10 degrees north to 10 degrees south latitude, centered on the equator. Key examples would be the Amazon basin of South America, the Congo or Zaire basin in in equatorial Africa, much of Indonesia and parts of Malaysia, etc., in Southeast Asia. And these are influenced strongly by the ITCZ throughout the year. Now, if you've got rainfall throughout the year, throughout most of the year, and every single month you're getting at least 2.5 inches or 2.4 inches of rainfall, then that's going to add up to significant rainfall throughout the year. So these places will get anywhere from about 60 to 150 inches of rainfall per year. Now remember, in Glendale we get 20 inches on average. A monstrous year might be 30, 35 inches of rainfall for us in Glendale. So we're looking at places here that average 60 inches to 150 inches or more throughout the year. Certain places will get as much as 460 inches of rainfall per year. Now, most of that rain is going to fall in the afternoon, but some of it around sunrise too. So if you're in one of these rainfall regions, you're going to get a significant chance of afternoon rainfall. As the air heats up, it's going to rise and give you these afternoon thunderstorms. Temperatures are usually very, very warm, anywhere from the high 70s to the low 90s throughout the year. So that's not, these are daily temperatures, by the way. So the high temperatures for the day might get into the 90s, and it might cool down into the 70s. So pretty warm places throughout the year. They have the smallest annual temperature range in the entire world. So 2 degrees to 6 degrees Fahrenheit would not be atypical. So if you say you lived in one of these regions, your difference between winter and summer would be pretty minimal, be pretty small. You'll get a larger difference between your daytime temperature and your afternoon temperature. So your morning temperature and your afternoon temperature. Your daily temperature range might be greater than your annual temperature range. And by the way, on these slides, when you see something underlined, it's probably pretty important. So again, the tropical wet, found very close to the equator, the tropical monsoon just on the edge, and the tropical wet and dry, a little bit more poleward of each of those. So here's a typical climate graph for the tropical wet. We see that the annual temperature range is very, very small. The temperature does not change throughout the year. The precipitation is pretty significant throughout the year. So on this axis over here, we've got 0 inches, 5 inches, 10 inches. This is basically by the month, we're looking at very close to 10 inches, maybe 8 inches, 8 again, 8 again, maybe 7. So significant rainfall every single month. So if you lived in this case, this is for Singapore, you would have pretty warm temperatures throughout the year and pretty wet conditions throughout the year. So it's going to be very warm and wet every single month. When do you go to Singapore if you don't like it to be humid and warm? The answer probably is never. The nice thing about Singapore, though, is they also have a lot of buildings with air conditioning that you can hop into to cool off. So don't avoid going to Singapore, just expect it to be moist and warm. The typical biome for the tropical wet is the tropical rainforest biome. These, again, are only found in areas of high year-round temperatures and high year-round precipitation. So right around the equator in South America, Africa, Southeast Asia, and the northeastern portion of Australia. Now these are home to thousands and thousands of plant and animal species. In fact, about half of all known plant and animal species are found in this one biome. It doesn't occupy very much of the earth, maybe 6 or 7% of the Earth's total surface, but is home to half of all the known plant and animal species. It's been around for 65 million years or so. That's a lot of time for it to find unique habitat and niches for species to exist. The typical vegetation we get there are very tall trees with big leaves, so we call these broadleaf evergreen forests or rainforests. Trees like mahogany and banyan and ironwood come from these forests. And most of the animals that we find there live in and around the trees. So a lot of arboreal or tree-dwelling organisms. This is a typical rainforest here. It's the top of the trees here taking in the sunlight and photosynthesizing, and a lot of shade down below. Now water is a very frequent feature here, so it cuts channels down into the rainforest, making areas for the light to penetrate through. This is a picture taken on the border of Brazil and Argentina at a waterfall called the Iguazu Falls. If you ever get a chance, you got to go check that out. So again, lots of rainforest trees with the shade below. So the floor of the forest is pretty dark. Lots of excess water and organisms that have adapted to live in and around trees. This is a frog, of course, but if you look at its little sucker cups on its feet, this is adapted to live on a tree, not so much to swim in a pond. So this is referred to as a tree frog. The rainforests themselves, we see different layers of life. The trees that can grow the tallest, the fastest, and maintain that space, these are the emergents. They could be a couple of 100 feet tall in many cases. So here we have the emergent layer. Most of the life is found in what we call the canopy. So these are trees that have grown up and their branches and leaves are spreading out and taking that sunlight as much as they possibly can in the canopy layer. Then we have the shady zones of the understory and the forest floor. So things fall down and things grow up. So the fruits, those will fall down onto the forest floor, branches, and decompose there. And basically that is another zone of life within the rainforest. But the majority is up here in the canopy. And think about that. There are snakes on the forest floor. There are snakes on the rainforest trees. There are birds on the forest floor, but most of the birds are going to be up here in the trees. The insects, yes, on the forest floor, but also most of the insects will be here where the life is growing, because less food is growing, that's what they're going to eat. This is a unique type of plant here called a epiphyte. That means an air plant. So this plant right here is growing on this tree. It's not part of that tree. And that's a common feature too. So birds will eat seeds, that poop out the seeds, and it can grow in a little environment on another tree. When it rains here, the nature of this plant allows it to basically pull the water down to its own root structure. We also have vines that grow in and around other trees in the understory. And then we have trees themselves. They don't want to waste their time putting their roots down deep into the soil. The soil is in fact not very nutritious, but the layer at the top, the humus layer, the humus layer is an area where things are decomposing very, very, very quickly, and those nutrients have to be recycled back up into the tree. So the tree has to grow as tall as it can, get that sunlight, outcompete everybody else. And it also has to provide stability for itself. So it grows these feet-like or bird feet-like structures that we call buttresses that will stabilize the plant, make sure it doesn't topple over if it's very, very tall. Again, here's a strangler fig growing around an existing tree. Here's a sloth. We see sloths quite often in the Central and South American tropical rainforests. In Malaysia, we don't get sloths. In forests like this in Malaysia, we might find orangutans. And one of the problems we're finding is through habitat destruction, people are coming in, cutting down the forest, burning them, chopping down the trees for various reasons, and growing instead palm oil for industrial commercial purposes. And that leaves a lot of orphan animals in these areas. The most important of which is the orangutan, and there's a lot of press about that and the dangers of deforestation in Malaysia and Indonesia related to the plight of the orangutan. Now, as we move a little bit out away from the equator, we get into our next zone called the tropical monsoon, or AM. So these are just on the edges of the tropical rainforests, but you notice that the annual rainfall might be a bit higher than in the tropical rainforest, because in the monsoons, the summer monsoons, the rains are so intense. But we do have a little bit of a drying period where 1, 2, 3, or 4 months in the tropical monsoon, we would get less than 2.4 inches of rainfall. That means the soil dries out, and that means that during that few month period, we might see competition for water from those plants, from those trees. So the trees tend to be a little bit smaller, and they're going to lose a few more leaves than a tropical rainforest. Also, we see a little bit more seasonality in terms of annual temperature range, so slightly higher in a tropical monsoon than it would be in the tropical wet. Largely, we see that with the daily temperature ranges too. So if we have a little tiny bit of seasonality, we're going to see that expressed in temperatures and in precipitation. Typically in a tropical monsoon, the hottest month is in late spring because shortly after that, the cloud cover arrives and we're going to see our warm temperatures peak, or hottest temperatures peak as we get into that late spring, and then they just plateau throughout the summertime. Now, some people just say that tropical monsoon also has a tropical rainforest climate. Not necessarily so. Other people say, well, those trees are a little bit different because they're going to drop their leaves during that short dry period. So we're going to call those a tropical semi-deciduous forest. In other words, they're going to drop not all of their leaves, but they're going to drop some of their leaves to retain their ability to keep the moisture inside during those drier months. Other than that, it pretty much looked like a tropical rainforest. So the monsoon areas is middle green color here, maybe a Kelly green that we find just on the edges of the tropical rainforest. A tropical monsoon climate might look a little bit different in the winter and in the summer, or in the summer being the wet period, the winter being the dry period. So here's a portion of, or a site I visited in Cambodia, and this is during the drier season. And looking during the wet season, it would be a little bit different. So during the dry season, that region of the world would have pretty low precipitation. The equivalent in Africa would be the same. But look in the wet season. Oh my gosh, the rainfall is off the charts. And you notice that, especially for Myanmar, temperatures were rising as we get into spring months and then just kind of plateau over the summer when the clouds arrive. So if you look at Cambodia during the wet season, lots and lots and lots of rain. So these are with warm temperatures and quite a bit of rainfall. If I were to visit Cambodia, I would probably visit during their dry period, or during the wet period, you're going to have to expect warm, sticky, wet conditions. So much so that cities in Southeast Asia, even in maybe in Bangkok, in Thailand, the water is going to build up and build up and build up and can't evacuate the landscape fast enough. So lots of excess water during that rainy summer season. The semi-deciduous forest we find, again, that's going to have them during the dry season lose some of the leaves, letting some sunlight come through to the forest floor, and that's going to allow more things to grow on the forest floor. Again, it looks like a rainforest, but the trees are a bit smaller, the leaves are a little bit fewer during that dry season. And other than that, same kind of species you get in both tropical rainforests and tropical semi-deciduous forests. So again, the rainforests in the green here, and the semi-deciduous forests on the edge, as to be expected, somewhat in alignment with where we find the tropical monsoon climates. Our third and final tropical climate is the tropical savanna. So the tropical savanna, or AW, sometimes called tropical wet and dry. Those are synonyms. So tropical wet and dry, tropical savanna is the name for the climate type. And again, we're now moving a little bit further still away from the equator, where we're going to be under the influence of the ITCZ for only half of the year and under the influence of the subtropical high for the other half of the year. That gives us 6 months of wet, 6 months of dry, typically, and about half of the total amount of rainfall you would get in a tropical rainforest. So where a tropical rainforest might get 60 to 150 inches of rainfall per year, we're now looking at, again, about half, 35 to about 70 inches of rainfall per year. Again, the warmest month will be coming in late spring because the clouds arrive in the summertime. And the vegetation or biome associated with this is, I'm combining a couple here. We're going to call this a tropical woodland, scrub, and savanna. Woodland means trees where the canopies don't touch each other. They don't interconnect. A forest, by the way, is the canopies of the trees hit each other, so the branches and leaves interconnect. In a woodland, they're separated. And if the trees are separated, that means more space between the trees for bushes, which we call scrub, and savanna, the tropical grasses, to grow. So this is an area of spread out trees with bushes and grasses in between those trees. Okay, Acapulco, Mexico, and Normanton, Australia. Now, remember, Normanton, Australia is in the southern hemisphere, Acapulco, northern hemisphere. We see a slightly raised annual temperature range. Here we're looking at about 5 degrees Fahrenheit. That's pretty low, but certainly larger than many tropical wet climate zones. We see about 6 months of dry, 6 months of wet, peaking in September for Acapulco, Mexico. For Normanton, Australia, in the northeastern portion of Australia, we have dry period during their, remember, this is southern hemisphere now, so we get into July, August, September, that would be their late winter. And then if we get into December, January, February, that would be their summer. So again, summer peak of rainfall and temperatures peaking in their late spring. I know it's a little confusing sometimes for southern hemisphere, northern hemisphere, but that's another clue to this temperature regime here. We can see that the hottest temperatures, it appears to be like November, December, and your initial thought is, whoa, that's got hottest temperatures in winter. No. Southern hemisphere, that's getting into their late spring, into the summer months. So if you ever see a temperature regime like that, hottest temperatures, December, January, etc., we know that's southern hemisphere. Again, tropical climates, A, F, A, M, A, W. So we're looking at the AWs over here, tropical savannas, this lighter of those colors on this map. Here I am a number of years ago in Tanzania, in the Serengeti, in a tropical savanna climate, a tropical woodland scrub and savanna biome. Checking out what was out there. We were camping out there, and these are baboons on the rocks. This is the photo is not enhanced at all. This orange sky is from all the dust being kicked up from the winds, and that dust will start to migrate off to the Atlantic and help form some of those hurricanes in the Atlantic later on in the year. So again, I'm combining a few or a couple of other biomes here, but we're looking at the biomes that are on the edges of the rainforest here. So this kind of mustardy and brown colors on this map right here. So for Africa in particular, we're looking here in this region. And what would we expect there? In a tropical woodland scrub and savanna, we tend to find trees, bushes, grasses. So again, woodland scrub and savanna found in the same general location as the tropical wet and dry or tropical savanna climate. We're going to get a little bit of seasonality. Remember, 6 months of dry, 6 months of wet. We're going to get trees, we're going to get some bushes, and we're going to get some grasses. So trees, bushes, and grasses. Now, we would normally see even more bushes here if it wasn't for fire. So the local people, they know if they set fire to the grasses burn away. This is after they've extracted the grains from the grasses, or after animals have done that. They will basically burn the grasses burn away, but they come back pretty quickly. The trees get a little scorched along their trunks, but it doesn't burn the tree away. The bushes get burned away and take a while to come back. So over time, with more burning, you're going to still have trees, and you're going to get a preponderance of grasses over bushes. Well, grasses have an awful lot of calories in their seeds. It's a good thing to have if you want to graze animals or raise crops. We often refer to this as parkland because of that mix of trees, bushes, and grasses. So if I use the word parkland, I'm referring to that mix of trees like this acacia tree and the bushes like African thorn bush and the grasses, which we call savanna grasses. This is also sometimes called big game country because this is where you're going to find elephants and lions, zebra, and wildebeest, etc. Here's a lion right here. And this is the thorn bush, the savanna grasses. And in the distance, there might be some trees over there. They've cut down some of the trees in this area. You can notice that the color of the lion matches very closely with the color of the grasses, and that's a very good adaptive strategy over years for, let's say, an evolutionary strategy for the lion's coat color to match that of the drying grasses. Very hard to find them. In fact, the first time I saw lions in the wild, the Jeep had stopped, and the guide pointed out to me the lion over there, and I said, well, I pointed out to him there's a lion over there. And he shook his head and says, no, 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 not lion. So I said, no, no, I know my animals. That's a lion. He says, no, not lion. Lions. And there are 17 lions around us. And hidden in the grasses, yawning away in the middle of the day. They were quite well hidden in the grasslands. Also, giraffes found in these areas, browsing on the African thorn bushes and the acacia trees, etc. The amazing thing about giraffes, their tongues are so long, they'll wrap around and just pull the leaves off of these very sharp, thorny bushes. So you thought you could get away from lions by climbing a tree? Not in the Serengeti, they've got lions that actually do climb trees. This lion in particular is finding the height of the tree quite an advantage in scoping out game very far away. So they're basically looking for animals that they could possibly hunt. Also, cheetahs out there, you notice the grasses, the occasional bushes. Now, some areas the soil just isn't right for trees. Sometimes it's too wet, too dry, not enough nutrients. So there are other factors that come into play, and we're ignoring many of those. And simplifying this by basically saying that all other things being equal, we would find these types of environments where the climate is just right. So we'd find a good connection between biomes and climate this way. In nature, it's a little tiny bit more complex. We also get tropical woodland, scrub, and savanna biomes in northern Australia, where they also have tropical wet and dry climate or tropical savanna climate. Of course, the species are a bit different, but we get bushes, some grasses in between. And this would be on the wetter edge here. So we notice that as it gets wetter, the trees are a little bit closer together, and when it's dry, the trees are further apart. So it's not just Africa where we get these environments. They are all over the world. The species look a little bit different. Okay, I'm going to end at this point and call that the end of part 1. And then I will continue with the rest of the climates in part 2. So I will bid you adieu right now and put this onto YouTube for you. And hopefully you'll have a little bit of an intro to the chapter of climate vegetation. And as you move forward into the B, C, D, and E climates and the highland climates, at least we have a template for how that's going to go. Okay. Thank you. See you soon.